All right, this will be a review for the upcoming similarity and right triangle trigonometry test. So let's jump right into the first two questions. It says a segment with a length of 3 inches is dilated with a scale factor 4. What will be the length of the image? And number 2 says a segment with a length of 3 inches is dilated with a scale factor of 0.25. What will be the length of the dilated segment? Now, if something gets dilated and the scale factor is bigger than 1, it's going to get bigger. So for number 1, we're just going to take 3 and multiply it by 4, and 3 times 4 is 12. So the length of the image will be 12 inches. Now, number 2, it says a segment with a length of 3 inches is dilated with a scale factor of 0.25. So what's going to be the length of the dilated segment? We're going to do the same thing. 3 times 0.25. And if you multiply 3 by 0.25, you get 0.75. So we'll have 0.75 inches. All right, next up, we're given this figure here, and it says identify, there's two parts. It says identify the scale factor if triangle AOB is mapped onto triangle COD. And then it says identify the scale factor if triangle COD is mapped onto triangle AOB. Now, triangle AOB is the smaller triangle. Triangle COD is the bigger triangle. Now, from here, we can see that this point A is at 0,2. This point C is at 0,4. Now, what that means, we know 4 is twice as big as 2. So we have a scale factor of 2 if you are going from small to big. Now, if you are going from big to small, then the scale factor will be the reciprocal of 2, and the reciprocal of 2 is 1/2. So for this particular problem, all we have to do is identify if we're going from big to small or from small to big. It says identify the scale factor if triangle AOB is mapped onto COD. AOB is the smaller, and if it's mapped onto COD, it's getting bigger, so my scale factor is going to be 2. Now, the next one says identify the scale factor if triangle COD is mapped onto triangle AOB. If you're going from COD to AOB, you're going from big to small, so the scale factor then will be 1/2. All right, next up. 4 says line segment C prime D prime is the image of line segment CD under a dilation with scale factor 1/3. If CD equals 15 millimeters, find C prime D prime. Now, C prime D prime is what happens after we dilate CD. And we know that our scale factor is 1/3, so we're simply going to take 15 millimeters and multiply it by the scale factor 1/3. We said in the previous problem, numbers 1 and 2, if the scale factor is bigger than 1, the image gets bigger. If the scale factor is a fraction smaller than 1, then it gets smaller. 1/3 is a fraction smaller than 1. To do 15 times 1/3, we can take 15 over 1, multiply it by 1/3. Multiplying by 1/3 is the same as dividing by 3, so we'll get 5. So our answer will be 5 millimeters. All right, next up, it says triangle NOP has side lengths 3 centimeters, 6 centimeters, and 9 centimeters. if triangle NOP is similar to triangle RST, which of the following could be the lengths of the sides of triangle RST? Now we have these as our answer choices. A, 5, 8, and 11. B, 2, 5, and 8. C, 6, 12, and 17. D, 2, 4, and 6. Now I've drawn two figures here, and we have NOP, and I've placed the lengths here, so 6, 3, and the 9. And we also have RST, and I've placed the lengths here. Now, I don't know actually if RST is going to be bigger or smaller than NOP. That's not really what I'm concerned about. What I'm concerned about is what will make them similar. If they are similar, and we were told the similarity statement here, triangle NOP is similar to triangle RST. Now, if they're similar, what is going to be true is that NO, the measure of NO over the measure of RS, NO over RS, is going to be equal to the measure of OP over the measure of ST. That's also going to be equal to the measure of NP over the measure of RT. Side NO corresponds to side RS. Side OP corresponds to side ST. Side NP corresponds to side RT. And what we'll have to do is plug in to see what works. So let's try A and see if that works. So for NO, I'm going to actually plug in 6. And 6 is going to have to go with 8. So be careful with that. That has to be equal to, let's look at OP, that would be 3 over 5. And side NP is 9. That's going to have to go with 11. Now, what you can do is you can cross multiply. That's one way to do it. I'm actually going to just type this into the calculator, so let's bring that up. Now, if you do 6 divided by 8, you get 0.75. That has to be the same as 3 divided by 5, and I get 0.6, so that's not going to work. Let's try, instead, we'll try B, the 2, the 5, and the 8. So let's get to writing again. I'm going to do 6 divided by 5. That has to be equal to 3 divided by 2. And lastly, 9 divided by 8. So let's try this and see if this one works. 6 divided by 5 is 1.2. 3 divided by 2 is 1.5. So that doesn't work either. So far, A is no good, B is no good. Let's try C. So I'm going to do 9. Whoops, we'll actually start once again with 6. So 6 over 12, that has to be equal to 3 over 6, and that has to be equal to 9 over 17. Now, be careful here, because 6 divided by 12, I shouldn't really need a calculator for this. 6 divided by 12 reduces to 1/2. 3 divided by 6, that also reduces to 1/2. However, 9 over 17 does not reduce to 1/2, so C cannot be the answer either. Well, let's hope that the answer is D, and let's try those. We have 2, 4, and 6. So I'm going to say 6 divided by 4 has to be equal to 3 divided by 2, and that has to be equal to 9 divided by 6. So let's type those in and see what we get. 6 divided by 4, we'll get 1.5. 3 divided by 2, we did that already, and we got 1.5. Last one we'll do is 9 divided by 6, and we get 1.5. So we get the same thing all the way across. Therefore, our answer has to be D. All right, next up. Let's look at number 6. It says, given angle A is congruent to angle X and angle C is congruent to angle Z, what postulate proves that the triangles are similar? And we're going to write a similarity statement. Now, remember that one postulate we can use to prove that two triangles are similar is angle, angle. And that means that we have two pairs of congruent angles, and that is exactly what we're given right here. We are given two pairs of congruent angles. The next thing we have to do is write the similarity statement. Now, it already told us A. I'm going to write triangle, little triangle symbol here. I'm going to start with the letter A, and I'm going to give myself some space, put a similarity symbol, write triangle, and then we'll go with X. Next up, it says angle C is congruent to angle Z. So I'm going to write the letter C here, and then write the letter Z here. Now, the only letter I'm left with in this triangle is B, so I'm going to say that triangle ACB is similar to triangle XZ, and the only letter left there is Y. So triangle ACB is similar to triangle XZY. There's a bunch of different ways you can write this, but I think that this would be the simplest way to go about it. All right, next up, number 7, it says triangle XZU is similar to triangle QSR, and it asks us to find the length of side SQ. Now, SQ, let's call that X. That's the side we're looking for here. So we're going to set up a similarity statement. SQ is the side that we're looking for. So I'm going to write SQ. SQ corresponds to ZX. So we're going to say SQ over ZX equals, now we have to use another pair of corresponding sides. And I'm going from, it looks like I'm going from a smaller triangle to a bigger triangle, so I have to be consistent. So I'm going to say RQ over UX. And now we're going to plug in. For SQ, we'll plug in X since we don't know what it is. For ZX, we'll plug in 24. Equals for RQ, we'll plug in 35. And for UX, we'll plug in 40. You can reduce 35 over 40 if you'd like, but I'm going to go ahead and cross multiply. So X times 40 is 40X. 24 times 35, let's go ahead and plug that into the calculator. So 24 times 35, you get 840. Our next step is to divide both sides by 40. And 40x over 40, that becomes x. And let's plug this in. 840 divided by 40. And a little trick to do this where I don't have to type in the previous answers, I just press the division sign, and you see A and S comes up. What that means is the answer from the previous problem, and we knew that to be 840, so I'm just going to put last answer divided by 40, 840 divided by 40, and we get that x equals 21. All right, next up, it says what proportions could be used as a given for a proof to show that line AB is parallel to line, this should probably be segment, line segment DF. Now, if these two lines, line segments, what have you, are parallel, then this piece, line segment AE, over this piece, so I'm going to write line segment AE over line segment AD is going to be equal to line segment EB over line segment BF. And that's all we'll say. This piece, line segment AE, the top left over the bottom left is going to be equal to the top right over the bottom right. All right, next up, number 9. It says triangle QRS is a dilation of triangle XYS. So QRS is a dilation of XYS with a scale factor of 5. It tells us SX is 3. So I'm going to write a 3 here. So the left side of the smaller triangle is 3. Now it wants to know how long is this piece here, XQ. Now what I'm actually going to do is first I'm going to find SQ, because SX corresponds to SQ. SX is the left side of the small triangle, and that corresponds to the left side of the big triangle. If SX is 3, to find SQ, I'm going to multiply 3 by 5. Now 3 times 5 is 15. So the left side of the big triangle is 15. If the left side of the big triangle is 15 and the left side of the little triangle is 3, in order to find XQ, that's the piece left over, what I'm going to do is say XQ is equal to SQ, that's the left side of the big, minus SX, that's the left side of the little. So 15 minus 3, and that is equal to 12. All right. Next up, number 10, it says what criterion shows that triangle ABC is, this symbol means congruent to triangle ADE. Now, you may at first glance think we're not really given much. However, you see here that both of these are right triangles. In order to show that two sides are congruent, we have a few different postulates, and that's what it's asking you for. What postulate can we use to show that these two triangles are congruent? Now, these are right triangles. As soon as you see right triangles, it should immediately pop into your mind that we'll probably be using HL. Remember, HL stands for hypotenuse leg. So let's see if that's what we may have here. Now, the 100 feet here and the 100 feet here, those two sides are congruent. Those are both legs. So right now, we have the L part. And if we wanted to show that the two triangles were congruent, we could also, or we would have to have these two sides congruent. Now, side AB would have to once again be congruent to side AD. Side AB is the hypotenuse of this triangle on the left. Side AD is the hypotenuse of this triangle on the right. So the criterion or the postulate we have to use is HL. All right, next, number 11. It says in the figure below, side TU, or line segment TU, is parallel to line segment, and that's supposed to be a QS. Use the proportionality of sides of similar triangles to solve for X. Now, we have two triangles here. We have a small triangle, and that is triangle RTU. So I'm going to call that the small. We also have a big triangle. That is triangle RQS. So that is the big triangle. Now, we have to set up a proportion. The trick is to use sides of each triangle. So let's do this. This TU is the base of the small triangle. That has to correspond to the base of the big triangle. So first thing I'm going to say is TU over QS. So the base of the small over the base of the big. I have to set that equal to something else. Now, we have a 2 here. 2 is the left side of the small triangle. That's going to correspond to the left side of the big triangle. I do not have the left side of the big triangle. The left side of the big triangle is this whole piece here. So TU over QS, I'm going to say, is equal to RT over TQ. Now, I'm sorry, not TQ, but RQ. I apologize for that mistake. So let's figure out what these are, what we're going to plug in. TU is 3. QS is X plus 4. RT is 2. Now, RQ, the distance from here to here, is this 2 and this X. Therefore, it is 2 plus X. So I have to write 2 over 2 plus X. If you put 2 over X, that's incorrect. Okay, so we're going to solve this proportion, and we remember that in order to solve a proportion, we cross multiply. Now 3 times 2 plus X, I'm going to write it like this. 3, and then in parentheses, 2 plus X. When I cross multiply this way, I have 2 times X plus 4, so 2 parentheses X plus 4. Our next step is going to be to distribute the 3, so here and here, and distribute the 2, here and here. 3 times 2 is 6. 3 times X is 3X. 2 times X is 2X. And 2 times 4 is 8. Now we have to solve for X. So in order to do that, we're going to want to get all of the variables on one side of the equation and all the numbers on the other side of the equation. So what I'm going to do is subtract 2x from both sides of the equation. By doing that, I am moving all the variables to the left side. If I move all the variables to the left side, I have to move all the numbers to the right side. Therefore, I'm going to subtract 6 from both sides of the equation. Now, the 6 and negative 6, they become 0. 2x minus 2x, that also becomes 0. 3x minus 2x is x. And 8 minus 6 is 2. Therefore, x is equal to 2. All right, we're going to stop here, and this will be part 1 of the video review.